Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion on the vector data model by talking about what happens when we move away from points. So one point, one coordinate pair, one object, to having multiple locations or multiple coordinates representing a single real-world object. And I think we can go through a pretty easy example of this. Let's go ahead and give ourselves a little bit more room here. Okay, so, right. So let's imagine that instead of measuring the fire hydrants, that you've been tasked with measuring the center lines of roads. So you've been tasked by the county to measure and map the center lines of roads. Okay? And so you think back to the fire hydrants that you've already done. You say, oh, vector data worked pretty well, right? I could go out with my GPS. I could stand on top of the fire hydrant, get the location, and that one location represented the fire hydrant as a point on the map. So you're like, I want to do the same thing. I want to use this same concept of vector data and apply it to roads. So you sit back for a second and say, wait a minute. Roads wouldn't necessarily be represented by a single point. And you would be right. So instead, what you would do is you would have what's called line or linear vector data models. And with a linear vector data model, right, what will happen is each discrete object is recorded with two or more coordinates. Right? And so I'm going to underline, right, two or more coordinates. So let's talk about how this might work in terms of mapping roads. So let's go ahead and let's create ourselves our little, so this would be the end result visualization over here. And let's say we have 3 roads. So we have road 1, road 2, and road 3 that we want to be able to have a good mapping result for. So we're going to go out and we're going to GPS or get the coordinates of 3 different roads. So the way this would work is you would take your GPS and you would go to the first road and you would stand at the beginning or where you wanted to start the road. So you would have your start X, you'd have your start Y, right? And so you would get the coordinates of that. So let's say this was maybe 10, 10, right? You would go some distance along that road and you would get another X and another Y. So I will call this X2, X3, and let's say maybe that's 15, 22, right? You would keep going, you would get another X, we'll say X x3. Oh, that should be y2, sorry. x2, y2. So you get x3 and you would get y3. Right, maybe this is 20 and let's say that it just makes a turn, 22. Right, and so then you keep going, taking more and more points until eventually you get to the end. Right, and let's say this is 25, 30. Right, so you can see here that rather than having a single coordinate making up our discrete object, in this case a road, right, we now have, in this particular case, 4 coordinates, right? We started here, then we went here, then we went here, and we finally ended here, right? And we can repeat that process for road 2, right? Find the place you want to start, so we would take the start x, start y. Let's say that this road starts at 5, 5, right? Go some distance, take more coordinates. Maybe this is 7, 7. And then finally, right, this road's a little bit shorter, so it only took 3 coordinates. So we would have our end, x, and y. And just for fun, let's say this road ended at the intersection where the first road started. Right? So each road in this case is being measured or recorded as multiple coordinates. You have a start, you have some intermediaries, and you have an end. And then when it comes to displaying them, I'm going to do this. I'm going to do road 1 in blue here. I'm going to do road 2 in purple, just so we can see the difference here. Right? What you do to display them, right, is you say, okay, start x and start y is 10, 10. So let's just say, for reference, let's say that 10, we'll say, is the midpoint of the map here. Right? So road 1 starts at 10, 10. And we'll say that the end here is 30, 30, 0, 0. Right, so we go from 10, 10. Then we go, so this is, then we go 15, 22. So we're going to go 15 and then up. So this is 15, 22. Then we go 20, 22. Right, and then finally we end at 25, 30. I know I'm not exactly drawing this perfectly to scale, but right, so we have 3 different points that represent the road. And what we do is we connect each piece up. So we now have a series of lines, right? So, right, this point, well, we'll talk about that in just a second. Right, so we have 4 different points, 4 different coordinates representing a single object, in this case, the first road in our data set. We then have the second road, which starts at 5, 5, which will go as roughly here, right? So this is going to be 5, 5. We'll go to 7, 7. We'll say that's like right there. And then finally, right, this road ended at 10, 10. So it's going to be on top. Right, and again, we're going to connect the lines. So what have we done? What we've done here, our visual output here, where we're displaying, in this case, 2 discrete features, road 1 in blue road 2 in purple. What we've done here is we've taken more than one coordinate. So we've taken, in the case of road 1, we've taken 4 coordinates. And in the case of road 2, we've taken 3 coordinates. So we've recorded the coordinates of a discrete object using more than one coordinate, right? And that's why I said each discrete object, in this case road 1 versus road 2, is recorded with 2 or more coordinates, okay? So this point right here in blue, right, represents the first coordinate. So that's this pair here, right, is representing part of the first road. But then we also have, right, we also have this coordinate here, right, being represented by this coordinate pair here, but also, right, still representing the same real-world discrete object, right? Both of these coordinates, right, 10, 10, and 15, 22, are both being used to describe one object. In this case, the first road that we want to map and measure, right? Conversely, right, if we go down here, right, this coordinate here, right, corresponds to this set of coordinates here, right, corresponds to the second real-world object, right? But we also have this coordinate too, right, corresponding to this set of coordinates, also corresponding to the second real-world object, okay? So I know I'm beating a dead horse here a little bit, but I want to make abundantly clear here that with the linear vector data model, what we're doing is we're taking more than one coordinate, so in this case 4, and in this case 3 different pairs of points to represent a single object. And then when we represent it visually, we connect the points together to form a line, which is why this is called a linear vector data model. So hopefully this makes sense. And as always, if you have any questions, please reach out. Thank you.